Yep, introduction to sequences. Very useful, especially if you think about financial application. So financial application is really in terms of geometric sequence as well as it's actually the first order recurrent sequence. So it's really useful. What you'll be learning is just basically arithmetic and geometric sequence. And we're going to talk about, for this lesson, as an introduction, define a sequence and sequence notation using subscripts. We're going to define recurrence as a process. We're going to perform basic operations with the sequence and define the concept of convergence, divergence, and limits. All right? So, if you look at something like this, I have got 1, 2, 3, 4, 5. 5 sets of numbers there. What can you tell about? Can you observe a pattern with A, B, C, D, and E? What sort of pattern? So A is plus 3. When you mean plus 3, what do you mean by plus 3? The subsequent number is the previous number plus 3, correct? What about B? Is there a pattern? Think about B. What about C? Is there a pattern? D? Pattern?
Yes.
Yes. And E? Is there a pattern?
Yes.
Alright. So I can describe the pattern, for example. A would be add 3 to the previous number. B, there's actually no pattern at all. C is a Fibonacci sequence. D, how I describe it, is not to the power of n. It's actually double the previous number. And E is subtract 5 from the previous number. So what I'm talking about here now is I'm looking at the previous number and then describe a process for the following numbers. So you've got a series of numbers. You start from the first number, you talk about what process you're going through. You're adding 3 to the previous number, adding 3 to the previous number. There's actually no pattern here, Fibonacci sequence, and then doubling the previous number. Starting from 1, I've doubled the subsequent number. And then starting from 5, I've subtract 5 from the previous numbers. So something like this is actually a sequence. A sequence is an ordered list with a pattern. So it must have a pattern. For example, 3, 6, 9, 12. I've got 3 dots. 21, 24, 3 dots. All right. This means there's a continuation, something in between that goes on and on and on. All right. But there's nothing before 3. So in this sequence, we can describe it as start with the number 3 and then add 3. Or starting with 3, add 3 to the subsequent number. All right? So the starting point is important. With the sequence, you've got to think about what is the starting point. And then each of the sequence, each number of the sequence is referred as a term of the sequence. For example, this is term 1, term 2, term 3, term 4, whatever, until term n. The way we write it is Tn, the term n, the nth term equals to first term, second term, third term, fourth term. So we can actually write this out, Tn. N is the placement of the term in the sequence. Right. Term 1, term 2, term 3, term 4. So that's the placement of the term, and this would be T1, T2, T3, T4. This is T7 and T8. All right? So this one means pattern continues, but terms has been skipped. At the end, pattern continues on forever and ever. It doesn't stop. All right? There's nothing stopping the thing from going on. You could stop here, which means there's a limit. If not, with the 3 dots, it goes on and on. And the 3 dots is called ellipsis. All right? That's for you to know. The 3 dots we use to just represent. There's a break and represent. It goes on and on. All right. Now, defining the recursive process. Recursion is the repeated application of a rule, process, or definition to give a sequenced answer. So recall for that set of numbers we looked at, we can describe it as starting with a number 3 and add 3. Example of recursive procedure. So therefore, if we want to express it algebraically, term 1, 3 is T1, T2, T3, T4, until you go to term n. So the term before term n is Tn minus 1. The term after term n is Tn plus 1. Alright? Now, here I've defined the first term. The first term is 3, and then we add 3 to the subsequent numbers. Alright? That's how you describe it. Depends, you can describe it the way you want as long as it's clear that there's a starting term and what is the process. Now, yeah, I've said that term before Tn and term after Tn. So you've got Tn here, before Tn and after Tn. Now, at this stage, we're going to define all our terms, starting term as T1. There will be situation, especially when it comes to finance, where you are going to start the term as T0 rather than T1. I'll talk about it a little bit later when we come to situation like that. Alright? So, one thing is with recursive process, you must always specify T1. If not, it is not going to be effective. If you don't know what the starting number is, you cannot. You can say 3 is added to the subsequent numbers, but what is the first number? How do you know which term to start off with? Where is the first term? So you should always specify T1. Alright? There are situations where T3 or T4 will be specified and you've got to work backwards. You'll be given certain terms and then you've got to work backwards to find T1. If you're given, for example, T4 is 3, and then the description is add 3 to all the others. So if T4 is 3, so you're going to go back, T3 will be 0, T2 will be minus 3, T1 will be minus 6. Alright, you must be able to work forward and backwards. So algebraically, I can say Tn plus 1 equals to Tn plus 3, and T1 equals to 3. So what I have described with this recurrence process is, this is the rule. Alright, go back to this one. So, term after Tn, Tn plus 1 is Tn plus 3. Correct? Yeah? So, here, what happened is, I can therefore, algebraically I can say Tn plus 1 is Tn plus 3, and I specifically say that T1 is 3. So therefore I know T2 is T1 plus 3. Correct? Yeah? Got it? Yeah. Now, can you explain in words the recursive procedure given by the following rules? I'm actually not going to write down my solution or the way I described it. I'm going to ask all of you to write down what you think, and I will get you all to, get one of you to actually give me your answer, and then we can discuss it. Alright, so I'll give you a couple of minutes to about 30 seconds per question. Now, just notice that this is written slightly differently. Tn equals to Tn minus 1 plus 2. It's still basically the same principle. If you know that we know what Tn is, we know the term before it is Tn minus 1, the term after it is Tn plus 1. So, alright, I'm going to shut my mouth for about 2 minutes. all this, you have to learn how to put it in your class pen. You put it in your class pen. Everyone done? Okay, I'm gonna get, let's say, eeny, meeny, miny, mo. Lucas, do you want to try to describe the first one? How would you say it?
Starting at 1 times by 3 and add 5.
Very good. So, starting with 1, the subsequent terms, it's multiplied by 3, and then 5 is added to that term. So that's good. Let's see, Hugo, how would you? Sorry?
I don't understand.
You don't understand? Alright. I'll come back to you in a few minutes. How about Leary? Yeah, second one.
Start with number 4 and add 2.
Yep. So starting with number 4, the subsequent term, 2 is added to the subsequent terms. Alright? So here, what happened is, now, if I start with 4, alright, I'm going to write it up. 4 plus 2, 6. And then 8 and 10. So starting with 4, 2 is added to the subsequent terms. Correct? And then you keep on going. And then you go dot, 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 dot. Let's go, yes?
What about the Tn minus 1?
Alright, now, Tn minus 1, Tn minus 1, Tn plus 1. It's all relative, isn't it? It's just a term. It's just a term number. It really doesn't matter. Alright?
Doesn't T1 mean that 4 is the first number in the sequence?
Yeah, that's what's supposed to be, but the way you describe it is how you do it. Just starting with 4, T1, the subsequent term is previous term. This means that there's actually a T0. Alright? T0 would be 2. Alright? Alright, we're not dealing with T0 at the moment. Let's not worry too much about that yet. Alright? Alright. So let's think the process is basically the same. The subsequent term is the previous term plus 2. Correct? Agree? Yeah? So it doesn't matter whether it's n minus 1, n plus 1. N plus 1 equals to that. So that plus 2 equals to that. I can also describe as this plus 2 equals to that. Correct?
Yeah.
Yeah? Alright, so I'm going to get rid of that bit, which is showing you the T0. I'm not going to get involved with T0 yet until a little bit later. There will be a situation where you're going to think about T0. How about number 3, Jessie?
Start with 3 and then times 4.
Yep. So starting with 3, the subsequent term is multiplied by 4. And finally, last but not the least, let's say, Milan, would you like to try the last one, please?
Start with 0, multiply by -2 and add 3.
Yes, that's good. So that's basically the idea of explaining it in words. Alright? You have your way of describing it, I have my way of describing it. As long as you remember, the process is always start with certain numbers and then describe the mathematical processes. Alright? So that's all I have for today, introduction to sequences. And now, I will talk about convergence, divergence, and limit. I probably shouldn't have actually put this in. The limit is when you have got a set which you've got something like now all of them I didn't have any limit on it. Or if you have limit, it's probably from 3, 6 to that bit, that's all. If there's a limit. Alright, I'll talk a little bit more about limit, divergence, and convergence a little bit later. Alright, you've got plenty of exercise to do in Sadler, and I'm going to stop here.